The broadcast is now starting. All attendees are in listen-only mode.
On behalf of RBCS, RBCS Australia, RBCS New Zealand, and Software TestWorks, we welcome everyone today to this webinar on advanced software testing with state-based techniques. I'm Rex Black, president of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, RBCS has been both a pioneer and leader in quality hardware and software testing. RBCS has offices in the United States, Australia, New Zealand, and Sri Lanka with partners around the world. RBCS delivers insight and confidence to our clients, helping them get quality software and hardware products to market on time and with measurable return on investment. RBCS has a team of international consultants that deliver customized training, consulting, and outsourcing services for companies that are looking to improve their test and quality assurance practices. RBCS has helped hundreds of companies reduce development and support costs while assuring the best quality products are delivered to customers. I'm the author of Pragmatic Software Testing, Advanced Software Testing Volumes 1 and 2, Foundations of Software Testing, Critical Testing Processes, and Managing the Testing Process. I have a degree in Computer Science and Engineering from UCLA. I'm also past president of the International Software Testing Qualifications Board and American Software Testing Qualifications Board. Before we start the presentation, a couple of housekeeping notes. If you have any questions during the course of the webinar, please feel free to submit them throughout the presentation via your webinar interface. There's no need to ask for presentation copies. The presentation is posted on the web at www.rbcs-us.com. If you're having problems with either the audio or visual components of this webinar, please contact GoToWebinar support. If for whatever reason you cannot get to the webinar online, or if you are dealing with an unreliable connection, please download the slides from the basic library at www.rbcs-us.com and use the telephone to connect, not voice over IP. Today, I'm happy to be presenting this webinar live in Seattle from a client's offices, CA, actually in Bellevue, not quite Seattle, but close enough, shouting distance. CA, like all RBCS clients, is a company that cares about testing and quality, and their local testing and quality staff are attending today's session. You might hear them making comments or asking questions in the background. But down to business. Today's presentation is the second in a multi-part series on advanced software testing. We'll do a few more of these, at least one more. Haven't decided exactly how many at this point. The material will come from my books, Advanced Software Testing Volume 1 and Pragmatic Software Testing. Today we continue with state-based testing. I chose to do this series of webinars on advanced software testing techniques because there are many powerful test design techniques developed over the last 30 years, but a few of these techniques are in use. So in a lot of cases, people aren't aware of the techniques or don't know how to use the technique or can't identify a situation where they can use it. So this series of webinars will help address those issues. Okay. So as I said, this is part of a series of webinars from Advanced Software Testing Volume 1. It's a book for test analysts and test engineers. So there are sort of fundamental techniques like equivalence partitioning and boundary value analysis, which are certainly useful testing techniques, especially if you're doing things like input field validation. You want to make sure that valid inputs are accepted and invalid inputs are rejected. But at some point, you need to start testing the business logic. We're really focused on what is the problem that the application is trying to solve rather than, what happens when I put illegal inputs in. Do they get bounced out or not, and what error messages do I receive? So in the previous webinar in this series, I covered decision tables. And anybody who missed that, there is a recorded version of that webinar posted on the digital library page on the RBCS website. So if you want to go catch that, you certainly can. This one, we're looking at state-based testing, and then there'll be another one coming up in a couple months that will cover use cases. And there'll probably be a couple more, at least probably one more on advanced or on pairwise testing, and then another one on domain analysis. So there's a few more that will happen in this series. But here we're going to focus on state-based. Okay, so state-based techniques have in common the idea that you're going to test the handling of some potentially arbitrarily long sequence of events that can occur. Now, by event, I mean something that happens external to the system being tested that the system being tested has to respond to in some way. Things that are not of interest to the application being tested are not events in this sense. Event means is very specific meaning here, external to the application, but of interest to the application. Now, underlying most of these techniques is one of two kinds of basic models. One can be a state transition diagram. I'll show an example of that in a minute. And the other can be a state transition table. And in both cases, whether the table or the diagram, what we have is a connection being established between the current state of the system, the event that is to be handled, in some cases a condition that can influence the way in which the event is to be handled. If the same event can be handled in two or more ways, we need to have some condition established that says, well, which of those ways do we take? And then, based on that state, with that incoming event or event condition pair, what is the resulting state and what is the action that the system is to take? Okay? So notice that the action here is what the system does in response to the event. Right, so the event is something that happens externally. The action is something that the system does when the event happens. The state is something that persists until an event happens to force a state transition. And so the system will remain in the state until one of the events that are defined for it to act on occurs, forcing it to make the transition. So you can think of it as a model for how the system reacts to various external things that can occur. So, given such a model, we want to derive tests from it, and usually what you're going to try to do is move from one state to another and move across what are called the transitions, which is where the event is handled, and verify that the system ends up in the proper state and that the proper actions have been taken. Now, in some cases, the state is transparent, and you'll be able to interrogate the system, if you will, to ascertain what state the system is in. In other cases, it's not transparent, and you just have to deduce from the action taken and subsequent actions taken whether it ended up in the proper state. So the way in which you check the expected result depends on how well the application exposes the state that it's currently in. Some applications will do that, some will not. So for example, if you think of like Word or PowerPoint, the state that the application is in is indirectly exposed by things like pop-up menus and what is grayed out versus what is accessible and so forth. So it's not going to necessarily tell you, here's the state that I'm in, but you can ascertain from the interface roughly what state it's in. Now, most of these formal test design techniques have this concept of a coverage criteria, which is how many tests can be generated from the model before the model runs out of useful suggestions for things to test. Now, in the case of boundary values, for example, we have to develop enough tests such that every boundary value is represented in at least one test, right? That's the coverage criteria for boundary values. Now, for state diagrams or state-based testing, excuse me, there are three criteria